Hi guys, welcome to another session on Math Academy. Guys, today we'll be doing Cauchy-Riemann equations, but before we go through that, I would like to give my thanks to everybody who has been supporting the channel, and thank you for the support, thank you for the feedbacks. We'll continue being a great video creators, and with you guys being on our side, we believe that we can achieve more in terms of the feedback. So we've introduced a new thing in our social media platforms, which we have at the end of the video. Please follow us on Facebook, Twitter, and Instagram, and then there we open for you guys to give us questions such that we can be able to do videos based on any and every chapter that you might have a problem with. It's not only for complex analysis, but everything pure mathematics in varsity level, BSc, we are here for you. So without wasting time, guys, let's go through the Cauchy-Riemann equation. So as I said, today we'll be doing Cauchy-Riemann equations. So basically in Cauchy-Riemann equations, guys, they talk about a function of complex variable, and we say that let's suppose that we have a function of complex variable which is given by u x y plus I v. It's just v x y. Okay, so this function has a derivative, and we are going to assume that this derivative exists. So if this derivative exists, then there must exist ux, uy, and vx and vy, which are just partial derivatives with respect to x and y. Okay, so if this exists, the derivative of that function of complex variable, then the partial derivatives of the components of this particular equation, or function of complex variable, then therefore this will have to exist. This must exist. And for us to say that this thing really does exist, these partial derivatives must, and I won't stress this any further, they must, okay, satisfy the Cauchy-Riemann equations, which we'll deal with them just now. But what I wanted to talk about is that the existence of all of these things, because if this exists, then these exist, and the existence of all of these things must happen at some point z0, which is given by x0 plus I y0. Okay, so the existence of the derivative of a function of complex variable gives us the existence of what? Of partial derivatives of the components of a function. So then if everything exists at this particular point, then therefore this equation x is equals to vy and uy is equals to negative vx. Then we call these equations that we have here at the bottom, these ones, the Cauchy-Riemann equations. Okay, so for us to say that the Cauchy-Riemann equations are satisfied, these two equations must be equal to one another. The two partial derivatives equations, they should be equal to these conditions have to be met. Okay, now actually this is basically everything that we have on Cauchy-Riemann equations, because like Cauchy-Riemann equations have to be met. But let us have an overview before we do some examples. We said that we have some function of complex variable, and if we have a function like that, its derivative will exist, and if it exists, the derivatives or the partial derivatives of the components of that particular function of complex variable must exist. And if they exist, they must exist at a certain point, which is z0, which is given by x0 plus iy0. And if everything exists, or if these 1, 2, 3, 4 things exist, then we will have to have this thing which is called the Cauchy-Riemann equations being satisfied. They must be satisfied. They must be satisfied. Okay, so if they are satisfied, then we can say that the derivative of this function at the point will be equals to ux plus I vx. Okay, now this ux and this vx, guys, they exist at a certain point z0. That's why we have z0 here. Okay, so let me not waste any more of your time. Let us try and look at examples. But guys, remember that the Cauchy-Riemann equations must be satisfied. It's a must. Okay, so let us check for an example. I don't want us to work too much or work over the video, so let us just look at these ones. So the first question, the question says that show that the derivative does not exist at any point f. Okay, for the equation not to, or for the, yeah, we can just say for the derivative to not exist. Let me just say that for the derivative to not exist, the Cauchy-Riemann equations should not be satisfied. These equations that we have here should not be satisfied. But if one of them is not satisfied, then therefore the other one, we don't even look at it. Okay, because like both of them have to be satisfied, not one but both. So in this case, in our first example, we can see that our uxy is this 2x and our vxy is equals to xy squared. Okay, so with us identifying these components or these u and v equations, then we can see that our ux, the partial with respect to x, is equals to 2, and our uy, the partial with respect to y, is equals to 0. So we'll do the same thing. Our v, the partial of v with respect to x, is equals to y squared, and our partial of v with respect to y is equals to 2xy. Okay, so if you check this, we can see that our ux, it is not equals to our vy. And with us seeing that, we can also see that our uy, it's not equals to negative vx, because look at this, this is 0 and this is y squared, and these two things are not anywhere close to being equal to one another. Then therefore we are going to say that f prime at z does not exist. Okay, so guys, I wanted to write does not, but yeah, it just happened like that for me. Okay, so if the Cauchy-Riemann equations, these equations are not met, these two equations are not met, then therefore we say that the derivative does not exist. So let us look at the second question, which is a follow-up. It's the same question actually, which shows that the first derivative does not exist at a point if the function is equals to this. Now, with this type of equation, e to the x multiplied by e to the negative iy can be written as e to the x, and by the, what do you call this, by Euler we have cos of negative y, which is just cos of y, minus I sine of y. Okay, so this minus comes from the fact that sine of negative y is equals to negative sine of y. Okay, so I didn't want to write too much of those things, so we can strictly we can just identify our uxy as e to the x cos of y, and our vxy as negative e to the x sine of y. Okay, so we have identified our ux and our vx. So now we need to find our partial derivative of u with respect to x. Then we get e to the x cos of y, and then we need our partial of u with respect to y, and we get now negative e to the x sine of y. Okay, now we check for v at x is equals to the partial of v with respect to x is negative e to the x sine of y, and then our partial of v with respect to y is equals to a negative e to the x cos of y. And as you can see again, that our ux is not equals to our vy. Our ux is not equals to our vy, and at the same time, we can see that our uy is not equals to negative vx. So if, or even here it's not equals to, if these conditions are not met, then therefore f prime of z0 does not exist. Okay, it does not exist. So practically we just we've just proven, or we have shown that the first derivative does not exist. Okay, so what happens, guys, is that if one of the conditions is not met, then the whole thing falls out, because both the conditions have to be met. And if the Cauchy-Riemann equations are met, then we can write the derivative at a point as ux plus I vx, where our ux and our vx are partial derivatives at a point z0. So guys, without wasting time, guys, and I see that we have ran over 11 minutes now, I'll just have more questions on Cauchy-Riemann equations on the next video. For now, thank you guys for the support. Don't forget to follow us on our social media. Don't forget to leave us questions. Don't forget to suggest, and the feedback is very much welcomed. Thank you very much, guys.